We are going to start the session today with the chapter Thermodynamics. I'm your chemistry tutor, Aparna Sharma. And before we start the session, let me briefly walk you through our website, how we are going to access the revision notes and the test in Classic site. If we go to classics.com and click on practice, and we are having different packages available here. Since we are doing NEET, let us go to NEET Premium. NEET Premium has it has test series for all the subject, and apart from subject wise, we are having NEET full test, and each subject will have n number of tests. And above that, we are having revision notes. If you click on revision notes, it opens in a new tab. And let us start the session today with the chapter Thermodynamics. So the very first question starts as, what is thermodynamics? Thermodynamics is defined as the branch of science that deals with the relationship between heat and other forms of energy. So immediately when we say it is a branch of science, or we can say branch of chemistry that is going to deal with energy, its forces and its interconversion. Or we could conclude that the simplest form of energy is heat. So simplest form of energy, when we say it as heat, we should study each in detail. And when we are learning thermodynamics, there are different terminologies which is very important. Before we go into the chapter, I would like to inform you that this chapter holds a very high weightage, that is almost around 8%. It is a very important chapter, quite lengthy, but we need to focus on this chapter because the weightage is high compared to the other chapters. So when we are dealing with important terminology which we will be coming across in this chapter is, first is universe. Immediately question arises, why universe? See, entire part that is surrounding us, we call it as universe. So in universe, we are learning about a system that is nothing but a part of your universe which we are, or you can say about which we are going to study, or about which we are going to make an analysis, or even you can say a part of universe that is under investigation, and that is under investigation. So when we say a part of universe that is under investigation, a term it is used is system. And apart from that particular system which we are planning to analyze, or about which we are doing the investigation or we are studying, except that, the rest of things is considered to be surrounding. And our system is classified into three types. It is open system, closed system, and isolated system. So we should know what is the difference between each, or what do we mean by open system, closed system, and the isolated system. So there is a transfer, or you can say there is exchange. When there is an exchange of energy and matter, when we say there is a exchange of energy as well as matter, then we consider that to be an open system. Similarly, for example, we can say a cup with tea. It is general. But when we are saying closed system, the only difference is you will have the exchange of energy but not matter. And here exchange means between what? Exchange means between system and the surrounding. If we have exchange of heat as well as matter, between the system and surrounding, we say that as open system. And if we say that there is an exchange of only heat between the system and the surrounding, we consider that to be an closed system, or we say that as closed system. And when which can, or the system which can neither exchange your energy nor matter with the surrounding, we say that it is an isolated system. The very simple example of our isolated system which we use in our day-to-day life is thermoplastic. And what are all, there are certain terms, it is very important to differentiate them or to know them. So what are all the terms? Very important term we should know is your internal energy, enthalpy, entropy, state variables. So there are many things which we should know before we proceed into the chapter. So the first thing we should know is your state of the system. What we say state of the system? The state of the system is nothing but the condition of the system which is being described in terms of certain observe, observable property, that is which we are able to observe. That is nothing but your temperature, pressure, volume. These are all the properties, or these are all the properties which we are able to observe it. Hence we call that as a state of the system. State variables, that is nothing but the properties of the system which we are going to call it as a state variable. Individual properties of any system, we consider that as a state variables. State function, it is the property that depends upon your initial and final state. But yes, path will not be considered. It is just the property which is going to depend upon the initial and the final state, but not on the path with which it travels from initial state to the final state. And yes, important is extensive property and intensive property. What do we say as your extensive property? It is nothing but that depends upon the quantity of the matter which is being contained in the system. But yes, it will not depend upon the nature of the system. It is, we can say quantity of matter should be contained in it, but it is irrespective of the nature of the substance. Example we can say as internal energy. So here we should know what is internal energy. Internal energy is the total energy inside a substance, or we can say it will be equal to the sum of your kinetic energy, potential energy, chemical energy, nuclear energy. So overall, if we say that there is an energy or the total energy inside a particular substance, we say that it is internal energy. And internal energy is an example of our extensive property. So in the same way, we are having intensive property. These are the properties that is not going to depend upon the quantity of matter which is contained in the system, but it will only depend, or it will absolutely depend upon the nature of the substance. So you could easily differentiate between the extensive property and the intensive property. Extensive and intensive, this depends upon the quantity, this depends upon the nature. Extensive property does not, for extensive property, nature of the substance does not matter, but for intensive it is very important. Like we can say your density, we can consider viscosity, all these things can be considered as a intensive property. And when we are talking about different numericals which is asked in thermodynamic chapter, it's also important to notice that the condition which they have mentioned, and that we say the term as your thermodynamic process. They will say so and so X and Y undergoes, or it is isothermally, adiabatically. So when they are using the word X and Y Z is undergoing isothermally, adiabatically. So what does they mean by saying that it is isothermally, adiabatically? What should we infer from it? So the infer is, or the analysis from the term being used in the numerical we should have is isothermal means your the process that is going to occur at constant temperature. So when in the question they say XYZ has undergone isothermally, or it has undergone a process isothermally, so immediately the takeaway from that should be that temperature is constant. If the process is undergoing adiabatically, adiabatically immediately means that there will be no exchange of heat or no heat exchange. In the same way, isoporic. Isoporic stands that it should have, or that particular process has a constant volume. The terms are very, very important. When I say isobaric, it should have constant pressure. Reversible, which all changes is going occurring in it will be, or it can be reversed. Irreversible, it is the process will occur only in given direction under a given set of condition. It is not going to be, you cannot get back that. So we say these terms are very important to note it, because it is being used in the exam. If the process is undergone isothermally, adiabatically, isoporic, whatever is given, the inference from that should be taken that in the question given, if volume is constant, or their heat is constant, or their pressure is constant, or temperature is constant, accordingly, this is very important. And next, yes, we have to study internal energy in detail. So as we discussed, internal energy is the total energy inside the substance, and it is going to be equal to sum of all the energies which is existing inside. So we all know that every substance will possess some energy from its origin. Every substance is going to possess some energy from its origin. Hence, the total sum of that particular energy, or if I say the total sum of energy possessed by that particular system, we call that as your internal energy. And obviously it is an extensive property, and the symbol used for it is U. The symbol used for it is U. And when we say that we are going to have change in internal energy, so what are all the methods by which the internal energy change can be achieved? So the two possibility is by heat and by work. But here it is very important to note that if we supply heat to the system, then we are supposed to take, generally heat is denoted by the symbol Q, and it is very important to note that when we are supposed to take heat to be positive, and when we are supposed to take heat to be negative. In the same way, when W is positive and when it is negative. So it is important to note that if we supply heat to the system, that means heat is being observed. Hence, it will take as positive value. And if we extract heat from the system, that means the energy is being released, or heat is being released. Hence, we can say that it is negative. In the similar way, we consider for work. If work is done on the system, it is taken as positive. If the work is done here, we have mentioned it. If the gas expands, work is said to be done by the system. In this case, W will be positive. And if gas is compressed, work is said to be done on the system. That means work done is negative. Whatever we studied regarding internal energy, the inference from that is here. what is internal energy and what we are supposed to remember in that, we have to consider that. And next comes is your first law of thermodynamics. What does first law of thermodynamics say? It is the law of conservation of energy. So when we say law of conservation of energy, what do we consider in it? Law of conservation of energy, it is a well-known fact that energy can neither be created nor be destroyed in any chemical reaction. But we all know it is always conserved, or we can say the sum of total energy of the universe is being conserved in it. So for example, how we are going, or we have a formula that is here delta U is equal to Q plus W. So suppose if I consider a system whose internal energy I consider it to be U, heat supplied is Q, work done is W, and the change in internal energy I assume it to be U2. So when I say as U2 minus U1, that is nothing but the final minus the initial, and which we say it as delta U, or change in internal energy. And when we say change in internal energy, it is your heat plus work done. Heat plus work done is our change in internal energy. And it is also important to note that we are having a relation between your joule and calorie. This is very useful to make a note, because we need to use this when we are solving the numerical in order to convert it. Okay. And next is the most important is your enthalpy. What is enthalpy? Enthalpy is nothing but it is the sum of internal energy and TP, that is pressure and volume. So suppose if I say that I'm saying there is, let us consider a reaction. A is getting converted to B. So each one is going to have a enthalpy. So if suppose I say H is equal to U plus PV, or we can say delta H is equal to, each one will be having a enthalpy, and from your product, if I subtract the reaction or reactant, product minus reactant will give us the change in enthalpy. And yes, we are having three different statement, or we can say heat capacity to study. That is heat capacity, it's general, specific heat capacity, molar heat capacity. So specific heat capacity or heat capacity and molar heat capacity, how we did differentiate each other, or how we define each other. So when we say heat capacity, it is nothing but the amount of heat which we require in order to raise the temperature of the substance by 1 degree Celsius. If being, that is whatever the energy or the heat we require in order to raise the temperature of any substance by 1 degree Celsius. 1 degree Celsius is very, very important. And hence we say that it is C is equal to Q by delta T. So how do we relate our heat capacity and specific heat capacity? Specific heat capacity is also the same, that is amount of heat required to raise the temperature of substance. But in heat capacity, we are talking to raise the temperature of substance by 1 degree Celsius. But here it is to raise the temperature of substance 1 gram of that substance through 1 degree Celsius. 1 gram of the substance through 1 degree Celsius. So here we are taking, additionally you will just take as mass, or Q is equal to, that is if you take it in the right other side, Q is equal to C into delta T. And here since we are talking about 1 gram, it is specific. for that particular substance, 1 gram mass. And molar heat capacity, it is the amount of heat required to raise the temperature. The name itself indicates here it should be 1 mole. It is very important. It should be 1 mole of the substance through same 1 degree Celsius. So here we are just talking a common 1 degree Celsius. Specific heat capacity, we say that as mass, that is 1 gram of the substance. Hence we are including M, and heat capacity 1 mole, that is 1 mole of the substance. These three formulae or these three concepts is very, very important in exam point of view. And when we say as your quasi-static process, the process in which change in any parameter will take place in such a slow speed that the value of your pressure, volume and temperature can be taken to be constant. Whenever we are having a change in process, whenever we have a change in process, but the process change or the transformation is very slow, that pressure, volume and temperature can be taken practically, it is basically taken to be constant. So in any numerical, if they are giving that it is a quasi-static process, so immediately we should understand that in the given question, pressure, volume and temperature will be constant, and then whatever data is required, we can substitute and get an answer. As we discussed, isobaric, it is a process in which your pressure is going to remain constant. That is also important to note, but the formula is also very, very important. So work done for isobaric process, immediately we all know that pressure is going to remain constant, hence we will have only change in the volume. And next, isoporic. So we know it is a process where the volume is going to remain constant. So if volume is going to remain constant, of course the system will do no work. So the inference from that is, once again, it's a highlighted point to make a note. Work done for isoporic process will be basically 0. It's very important to note that. And heat capacity, amount of heat, formula, we have mentioned it. And hence it is important that knowing heat capacity or molar heat capacity or the specific heat capacity, it is not enough, but we should also know how do we relate that with the other formulae, or from the given values, how we are able to apply that formula. So next concept comes is your very important relation. We all know Cp minus Cv is equal to Cp minus Cv is just the different concept of our molar heat capacity, or we can say types of molar heat capacity, Cv and Cp. Cv heat capacity where we are having constant volume, and yes, Cp heat capacity at constant pressure. I stress again, it is molar heat capacity. Molar heat capacity at constant volume, molar heat capacity at constant pressure. The relation is very, very important. So how do we reach to that relation? Cp minus Cv is equal to R. We all know, or just now we have discussed the formula as Q is equal to N into C and R delta T. What, and at constant pressure, the same formula, just we have to include as your constant pressure, constant volume. But the important thing to remember in this is this one. If we have molar heat capacity at constant pressure, it is change in enthalpy, and molar heat capacity at constant volume, it is equal to internal energy. So immediately just it is a replacement of in the formula delta H is equal to delta U plus delta PV, and we can say as PV is equal to nRT, because since here we are talking about 1 molar heat capacity, the concept itself says that it is for 1 mole. Hence we could say N value to be, because we know it is PV is equal to nRT. Since N is equal to 1, we get PV is equal to RT. We can substitute that, and we could conclude that if we substitute the values of each in this equation, we all know delta T is common, we can cancel, and you will get Cp is equal to Cv plus R, or Cp minus Ev is equal to R. And we are having different types or different formations of reaction, that is your enthalpy of reaction. Enthalpy of reaction has different terms, that is enthalpy of formation, enthalpy of combustion, enthalpy of solution, neutralization, and many more. So each one is important to know. If I say enthalpy change in a chemical reaction, or what is this enthalpy of reaction? It is simple that the amount of heat it is being observed or released in a reaction when the number of moles of the reactant is going to react with specified moles, or to form a completely, to form the product, or we can say to form the complete product. So whatever the amount of heat it is being required in order to change the reaction, or in order for the reactant to form a product. So during the reaction, both the chances are there that energy can be released or energy can be observed. In that we have, first one is your enthalpy of formation. So enthalpy of formation, the name itself gives the definition that enthalpy change when 1 mole of substance is formed from its element, because it is formation. So, and the element, whenever the elements are in their most stable state, we consider that as the enthalpy of formation. Enthalpy of combustion, it is a known value, energy change when 1 mole of substance is completely burnt in presence of oxygen. So enthalpy change, sorry, and hence when we are talking about combustion, it is very important to know what is heat engine. Heat engine is substance that is going to convert heat energy and chemical energy into mechanical energy. And conversion alone is not important, because we should know the efficiency. Efficiency of an engine is nothing but it is the ratio between the useful heat, that is heat converted into work, to the total heat supplied to that engine. And when we are talking about enthalpy of reaction, we say that energy is being released and energy is being observed. Hence, this is very important to have in mind, that your delta E will be negative for exothermic reaction, while it is positive for endothermic reaction. It is very, very important, because when we do the numericals, we should know this condition. Then only we will be able to take the value of our delta E, whether it should be negative or positive. So for exothermic, it is negative. For endothermic, it is positive. And yes, entropy. Entropy is nothing but the degree of your randomness. That is, entropy is denoted by the symbol S, and delta S is equal to Q by T. And amount of energy which is being unavailable, or that is what we use the term as degree of randomness for the conversion, or for the term entropy. So when we say entropy, what we define or how do we relate our entropy with other terms. So entropy immediately says that it is the energy of the, or we can say randomness. So amount of energy which is being unavailable for doing any sort of useful task, or amount of energy which is unavailable for any reaction to take place, we say that term as entropy, and it is denoted by the symbol S. And yes, it is very important to also know the relation or how we relate our entropy with P, and how do we relate our entropy. So we will be having entropy of fusion. Entropy of fusion, we can say S is equal to Q by T, the same formula, but it depends. Entropy of vaporization, entropy of sublimation. So each condition when they are giving, it is important to note that what we are considering the value. And yes, the second law of thermodynamics. Second law of thermodynamics is very useful, or it is being used in order to calculate the spontaneity of the reaction. And when they ask spontaneity of the reaction, or the question it will be asked is, they may give some option and they may say, choose the option which reaction is spontaneous or which reaction is non-spontaneous, or what are all the conditions for a reaction to be spontaneous. So we should always have in mind, if the delta S value is greater than 0, it is a spontaneous reaction. If delta S is equal to 0, the reaction is at equilibrium. And if delta S is less than 0, the reaction is non-spontaneous. So condition to have in mind is also an important factor. And if we say what is S total or what is entropy total, so it is nothing but the sum of the system as well as the surrounding. And what are all the factors which will affect the entropy, or what are all the factors which can disturb the entropy? It is the mass, molecular structure, temperature, and pressure. Yes. So it is important to note that how the entropy is getting affected, and what are all the conditions of entropy, that it is the reaction is spontaneous or non-spontaneous, or the reaction is at equilibrium. The conditions are very, very important. And next is Gibbs free energy, that is denoted by the symbol G, and it is also the, or it is also defined as the amount of energy for a system which is required or which can be converted into useful work. The energy or the amount of energy for any system that can be converted into useful work, we say that as Gibbs free energy, and it is denoted by symbol G, and there is a relation as G is equal to H minus Ts, or if I say change in Gibbs free energy, it is delta H minus T delta S, and of course this is an extensive property. So here also it is important to note the condition again, that when the, or depending on the value of delta G, how we say that the reaction is spontaneous or non-spontaneous, or it is at equilibrium. In exam, many questions are being asked based on the condition. So if suppose I say delta G is negative, then it is a spontaneous reaction. If your delta G is equal to 0, of course it will be at equilibrium. And if delta G value is positive, then it is non-spontaneous. It is non-spontaneous. So in spontaneity, if we are talking about relating, we can say that delta G is equal to delta H minus T delta S. And this equation will take into account the concept of both your energy factor as well as entropy factor. And in this chapter, the last thing we should remember is that is third law of thermodynamics. At absolute zero, the entropy of perfect crystalline will be zero. So we can say that there are certain substances which possess certain entropy even at absolute zero, and when it is possessing entropy at absolute zero value, it is considered as a term that is called as residual entropy. It is called as residual entropy. So by this, the concept of thermodynamics comes to an end. Based on our study and analysis, let us do a test and see. So when we go to chemistry, we have each subject, each chapter has a test. The green bubble indicates that the test has been taken. Blue says that it is yet to be taken, and R is a random test. But yes, even if the test is taken, we can take that test n number of times unless and until we feel confident in that particular test or we know the answer of all the tests. So for today's session, let us do a test from the chapter thermodynamics. So the first question says, when is the efficiency of heat engine maximum? As I told you, what is heat engine? Heat engine is the system that is going to convert heat energy and chemical energy into mechanical energy. And we know that efficiency of an engine is defined as the ratio. So it is important that useful heat, or it is a ratio between the useful heat or heat is being converted to work and the total heat supplied to that an engine. So when I say based on this question, what is the efficiency or when is the efficiency of heat engine maximum? So from the given point, we could conclude that the temperature difference of the source and sink should be maximum. Then only your efficiency will be maximum, because your efficiency of heat is ratio between useful heat to the total heat. Hence, the temperature difference should be maximum. So let us mark and then go to next. Okay. At constant volume, the heat of combustion of solid benzoic acid is minus 321.30 kilojoule at 20, and we have to calculate the heat of combustion at constant pressure. So we have to, let me solve it. So they have given us, as I told you, the very first step should be to write down or to make a note of what is given in the question. So when I say benzoic acid, it is C6H5COOH, and that is undergoing combustion. So O2, and it will give you, it is a known fact that it will be carbon dioxide and H2O. It is very, very important to balance the equation. It is very, very important to balance the equation. Hence, it should be 15 by 2 O2, 7 CO2, and 3 H2O. And here we all know what is the formula. Delta H is equal to delta E plus delta Ng RT. We need to calculate delta Ng RT. That will be nothing but delta Ng is equal to your product minus your reactant. Hence, we have 7 minus 15 by 2, which will be minus half. And this value can be substituted here. Delta E they have given in the question as minus 321.30 minus this we have calculated as half into R into temperature 300 Kelvin. So when we calculate this, see, just because we are having in the option we have R value, that is why I have not substituted the value of R. If we subtract this, or it is minus 321.30 minus 3 or 300 means 150 by 150 R. So let us see if it is there in the option. Yes, it should be minus 321.30 here, minus 150 R. Save that and go to next. The reaction SO2 plus half O2 will give you SO3. It should be an exothermic, endothermic, or it is unpredictable. So when I see a reaction, how could I say that whether it is a what type of reaction it is? I think I clicked 2 times. Third option. Sorry. The question says which of the following relationship is not correct? Immediately all the analysis which we discussed, what is delta H value, how your delta S is possible, or what should be the value of delta E. So from this we can say that your delta H is less than delta E for combustion of carbon to carbon. This we all know it. It is a fact. Just save and go to next. The reaction SO2 plus half O2 will give SO3, and that should be what will happen to our SO3. So the reaction is going to involve decrease in randomness, or hence you could say that the spontaneity must be favored. And if spontaneity is favored, because delta H is negative, and if delta H is negative, immediately we can say that it should be an exothermic reaction. Okay. Next. Here it says 1 gram of diamond atom of graphite and 1 gram atom of diamond were separately burnt on carbon dioxide, and the amount of heat liberated were 393.5 kilojoule, 394.5 kilojoule. So they are saying, since here we can say that graphite on combustion is giving less heat compared to the or to the diamond. Since graphite is giving less heat content, that means we should understand from that that it is more stable compared to diamond. So which option supports that graphite is more stable than diamond? So graphite is more stable than diamond. That is our answer. Let us save. Next. Hence, it says that next question is enthalpy of neutralization of strong acid on strong bases has the same value because why the enthalpy of neutralization and enthalpy of all strong acid and strong base will have the same value. We all know that the enthalpy of neutralization and of strong acid and strong base will have same value because the net chemical change which is being involved in combustion of 1 mole of whether it is H plus or OH minus, it is going to form water. It is a fact that whether chemical change it is being involved in strong acid or strong base, whether it is 1 mole of H plus or 1 mole of OH minus, the ultimate product is going to form water. So if we check the option, which should be the net chemical change, this should be the answer. Save and go to next. The value of delta S is negative in which of the following process? Where based on the examples, it is all an examples of entropy, and we have to analyze whether it is a whether the delta S value will be negative or positive. So if I check from the given option, we can say that basically the rubber band, it is long, flexible, and macromolecules coil, and they will coil up in random way. So whenever it is being stretched, whenever we try to stretch it, it will get back or it gets uncoiled, and hence the uncoiled arrangement will have more specific geometry. Thus we can say that the change in entropy is negative. So the answer should be stretching of rubber band. Let's save and go to next. According to third law of thermodynamics, the entropy at 0 Kelvin is 0 for, as we discussed, what is third law of thermodynamics? According to third law of thermodynamics, the entropy of perfect crystal is 0. The entropy of perfect crystal is 0. Hence, when the temperature of the crystal is equal to absolute 0, so the entropy of perfect crystal at absolute 0 will always be exactly 0. Hence, it should be perfectly crystalline solids. Just save that and go to next question. The sign of delta G for the process of melting of ice at 273 Kelvin and 1 atm pressure is. What are they trying to convey from that? Melting of ice, we should know that it is spontaneous above 273 Kelvin. The reaction, the melting of ice is a spontaneous reaction, but the condition is above 273 Kelvin, not at 273 Kelvin. So at 273 Kelvin and 1 atm, that it should be at equilibrium. And if it is the reaction given is equilibrium, that means we know that delta G will be 0, hence it should be neither negative nor positive. The only difference or the change in the question is if here it is about 273 Kelvin, then value becomes negative. If it is at 273 Kelvin, it is at equilibrium, hence it should be equal to 0. If in the option, if they would have given 0, then that should have been the right answer. Since we do not have that in option, we could say that the answer is neither negative nor positive. Let us save that and go to next question. For the following thermodynamic process, dry ice to carbon dioxide, what should be the value? So immediately when we say both delta H and delta S, what should be the value of delta H and delta S in the given reaction? So dry ice to carbon dioxide, it is said. Dry ice to carbon dioxide. So when I say dry ice to carbon dioxide, this reaction name, or we can say that this reaction is known as sublimation of dry ice. The reaction is known as sublimation of dry ice. And delta H will be positive because when it is undergoing sublimation, heat is observed during the reaction. And if I say delta S, conversion of dry ice to carbon dioxide, it is more or less, it is an ordered arrangement. It is a following a specific procedure. And hence you can say that ordered arrangement as compared to carbon dioxide gas. So here randomness will increase, and hence we can say that delta S is also positive. So we could conclude that delta H is positive and delta S is also positive. That means option D, both delta H and delta S are positive. That should be the right answer. Let us save that and go to next. At 298 Kelvin, the enthalpy change for a given reaction K is minus X calorie per mole. And if the reaction occurs spontaneously at 298 Kelvin, the entropy change at that temperature. The entropy change at that temperature. How we are going to calculate? We all know that they are asking us to calculate the entropy change. So if suppose I use the Gibbs free energy formula, that is delta G is equal to delta H minus T delta S. So delta G is equal to delta H minus T delta S. And since they have given that the reaction is spontaneous, we know that delta G is less than 0. And delta H, they have given it to be minus X kilocalorie. And the temperature is 298 Kelvin. So it is very simple. If we substitute the value of your delta H and the T value in it, we could conclude that delta S will be negative, but it will be less than X by 298 calorie per Kelvin. It will be negative, but the value should be lesser than X by 298. So negative, but numerically it is smaller than X by 298. Hence our option should be, let us save that. And next one is, what percent T1 is of T2 for a heat engine whose efficiency is 10%, whose efficiency is 10%. So as we discussed, what is efficiency of heat engine? It is, here we have the formula, efficiency of heat engine, ratio between useful heat to the total heat. So when I try to calculate that, we say that it is equal to 1 minus T1 by T2. Here they have given this to be equal to 10%. And if I want to calculate T1 by T2, I'll get it as 1 minus theta, or 1 minus 0.10, because it's 10%. We'll get it to be 0.90, or it is approximately 90%. But this is the value of T1 by T2. It is a ratio. T1 by T2 is equal to 90%. That means T1 is equal to 90% of T2. Let's see if we have in the option. Yes, 90%, because what percentage T1 is of T2? Do remember, they may change this T2 to T1 if the ratio they ask. Accordingly, we should answer it. But here it is T1 is to T2, so it is 90%. Let us save that and go to next question. An ideal gas expands from 10 to the power of minus 3 to 10 to the power of minus 2 at 300 Kelvin against a pressure. The work done on it is work done, they have asked us. So what is the formula of our work done? Work done is equal to, see, work is equal to force into displacement, or work is going to be another form of the same work done, because the given values based, this is the basic formula for the work done, but here our given value is in the form of expansion, that is our pressure and temperature. So the work done formula which we are supposed to use here is, work done is equal to minus P delta V. P they have given us to be equal to 10 to the power of 5 Newton meter, or which is nothing but your 1 atm. Delta V change, it's given 10 minus 1, that can be equal to 9 liters. And hence we know P and delta V, we can substitute in W, that is minus of 1 into 9 into 101 divided by 1000, and hence we get W is equal to 0.9 kilo. Here the question will arise why we have used 101 here, because we all know that 1 liter per atom is equal to 101 joule. We need to convert that. Hence, let us see if we have 0.9 kilojoule as the answer and it is a negative value. Save that and go to next. Given delta H ionization of HCN, ionization of CH3Cl, which one of the following fact is true, we need to find out. So as we discussed, we have one acid. They have given us the ionization value for two different acids. So we should remember, or it is a fact that when, or it is a hint to solve such type of question, that always remember smaller the value of pKa, that is your smaller the value of pKa, stronger will be the acid. So whenever we calculate the value of pKa, we can say that based on the value of pKa, we could decide whether the given acid is a strong acid or weak acid. So HCN is having the greater heat of ionization, and that means it should be a weak acid, and if it is a weak acid, its pKa value will be higher. So from the given option, pKa value of HCN is greater than pKa value of CH3COOH. I repeat, smaller the value of pKa, greater will be the, or we can say stronger will be the acid. Here if you compare the ionization value they have given is higher for HCN. Hence if the ionization value is higher, that means HCN is a weak acid compared to the other one, and if it is a weak acid, pKa value will be higher. Hence option D should be the right answer. Let us save that. Go to next. They have given us different reaction, that is N2 plus H2 is 2NH3, and that is delta H1. H1 plus Cl2, 2HCl, that is delta H2 NH3. So if you try to relate in terms of delta H1, H2 and H3, we should find out the formation of NCl3. As we said, we have to find out the heat of formation of NCl3. That means what? How? NCl3. That means N2 has to react with Cl2 in order to give us NCl3. So this reaction we should obtain from the other three reactions they have given us: N2 plus H2, H1 plus, Cl2 plus H1. Three reactions they have given. From these three reactions, all sorts of addition, subtraction, all trial and error it is, you have to do, and then we have to conclude that we are able to reach to the reaction of the formation, that is NCl3, and this concept it is termed as Hess law. Using the different formation of the reaction, we should reach. So first reaction which they have given is NH3 plus Cl2. It is given as NCl3 plus your HCl. So I would suggest that delta H value minus H, that is your delta H3, plus half of delta H1 minus 3 by 2 delta H2. Delta H will be equal to H3 plus half of delta H1 minus 3 by 2 delta H2. If we do this combination, you will get the reaction N2 plus Cl2 will give you NCl3. So the resulting equation what we can get, you will get it as half of N2 plus 3 by 2 Cl2 will give you NCl3. So for that, what we have done in formation, we have done that is, sorry, it should be delta H3 plus half of delta H1 minus 3 by 2 delta H2. So when we subtract or when you substitute the value given as your delta H1, this one you will get the answer. So here the formation, as I said, it should be minus your delta HF is equal to minus delta H3 plus delta H1 by 2 minus, I'm just saying in this reaction we need to substitute the value. Here this for N2 plus 3H2 2NH3 it is delta H1. So in delta H1 we have to divide by 2. That means this full reaction should be divided by 2. If I say delta H2 it is 3 by 2, that means this value H1 plus Cl2, this whole reaction is 3 by 2, and then subtract delta NH3, that is minus delta H3. Hence if you subtract that, you will get this equation, that is our formation of NCl3. Hence that is the ultimate value for the delta HF, or we could say formation of NCl3. So our option A is, I think I did not mark 3. So let us end the tense since we have completed all the 15 questions. Once you end the test, please have an eye on the time, because knowing the answer alone will not be important, but solving the answer, solving the question in the given duration is also important. Here the green color indicates that we have given all the question to be right. And if you click on each question, suppose if we are gone wrong with any of the question, if you click on the question, it will give you the right answer as well as the explanation how we reach to the right answer. So you could go through each question wherever we are gone wrong, and you can get a clear explanation about the answer as well as the formula being used and so. And the revision notes will help you to simplify your work to do a quick revision for the chapter. And I repeat once again, thermodynamics is a very important chapter, so to prepare well. Swapna, is there any question?